Hello TKG Army, another lecture from circular motion, and this lecture is very important, students. This lecture is related to the topic which is named as banking of a road. So what is banking of a road? You must have seen that when we take a turn in a busy highway, in an important highway, in a national highway, at the turning position, you must have seen that the road becomes inclined like this way. You see, this is the horizontal road, but at the turning point the road becomes inclined like this way. This is the inner edge and this is the outer edge. The road becomes inclined, not very high. This is inclined, you can see basically in important highway, in a national highway, not in all types of roads. Now question arises in your mind and my mind also, why these types of inclination is required? What is the relation with these types of inclination with circular motion? So this is our today topic. So open your copy and write down the notes, and once again welcome to your channel TKG Physics Classes. So first of all you have to write down the definition of banking of curved road. You see the definition: the system of raising the outer edge of the curved road above the inner edge is called the banking. The outer edge, like this way, outer edge is curved with respect to inner edge. This is the inner edge and this is the outer edge. This is the banking, and the angle through which the outer edge of the curved road is raised from the inner edge, this is the angle of banking. You see, this is the inclination. The road becomes inclined like this way. You can imagine, no? This is a 3D figure. This is the inclination, and this angle theta is known as angle of banking. Okay, so for knowing this part, at first you have to know the basic mechanism of turning of a car on a level road, which we already completed in last lecture. What is the basic mechanism? You see, when a car takes a turning on a curved road, what is the basic mechanism? The turning. So at the turning point, you see, at the turning point, what happens? At the turning point, you feel that you are going outward through the circle. So when you going outward, friction arises, and frictions gives the direction in the inward towards the circle, along the radius of the circle. This frictional force is provide the centripetal force which is required for taking a turn of a car. You understand this part in another way also. There is a force which is named as centrifugal force. What is centrifugal force? Centrifugal force is basically pseudo force, and which is act in a non-inertial frame. You know, na, inertial and non-inertial frame. There are two frames of reference: inertial frame of reference, and there is another non-inertial frame of reference. In inertial frame of reference, Newton's second law, F equal to m into a, that is valid. Newton's second law is not always valid. Newton's second law is valid for inertial frame of reference, where acceleration a is equal to 0. That is, the body is under uniform motion. But in non-inertial frame, when you are observer, you are in the car, you are moving. This is the non-inertial frame. You have acceleration. Acceleration is not equal to 0. In that condition, a force arises by which you can going like this way, outward. This force is known as centrifugal force, and this force is also value, that is mv square by r. But there is a negative sign, that is, it is directed outward, and the centripetal force, that is directed inward. So when you are going outward, there is a centrifugal force, that is mv square by r, and in inward direction there is a force of friction, that is must be equal to this centrifugal force. For taking a safe turn, must be equal to or greater than. or you can understand this part in another way also, that is when a car is moving along a circular path, you must require a centripetal force, and centripetal is not a new kind of force. This force is developed with the help of another forces. Here when you take a circular turn, the force of friction is required, and this force of friction is converted into the centripetal force. So this is the basic mechanism. Now question arises, why banking is required? Why banking required? See, suppose we consider a road, you consider this road, that is smooth road. Okay, this ideal case, road is basically rough. You consider this road is smooth. So when you moving this smooth road and you are taking a turning, what happens? Basically you are going outward through the circle when taking a turn, but there is no inward force. Why no inward force? Because the road is smooth. The force of friction F is equal to 0. So this force of friction cannot provide the centripetal force. This force of friction cannot equal to this outward force, that is centrifugal also. That's why we required the banking of road. That's why we required the banking of road. Now we will discuss this one, the circular motion of a car on a banked road. What actually happens? You see the diagram, a car of mass m. So obviously weight, that is mg, which is directed vertically downward. A car of mass weight mg is going along a circular path of radius r. This circular path has radius, this radius is r, and this is a speed v, moving with speed v on a road banked at an angle theta. This is the angle theta, and this is named as the angle of banking. Now you see here, weight of this car is directed vertically downward. Weight W is directed vertically downward. Okay, you make this one separately. See, this is the horizontal line. Sorry, this is the horizontal line. This is the angle of inclination. This angle of banking. This is a car. So this car weight is directed W, that is vertically downward. Now you see carefully, this angle is theta, this angle is 90 degree. So obviously this angle will be 90 minus theta. When this angle is 90 minus theta, this angle is 90 minus theta, this angle will be also 90 minus theta. Clear? Okay. So here you see, what is the direction of normal reaction force? Generally, a body is placed on a horizontal surface, normal reaction force is directed vertically upward, perpendicular to the surface. But here the surface is inclined, this surface is inclined. So obviously the normal reaction force is also will be inclined like this way. So here normal reaction force is directed in that direction. This is the normal reaction force R. So you see, this is perpendicular, this total angle is 90 degree, this total angle is 90 degree, but this angle is 90 minus theta. So obviously this angle is theta. Clear na? This angle is theta, this angle is perpendicular, that is 90. So obviously this one will be 90 minus theta. That's why the summation is 180. So when this angle is 90 minus theta, this one is 90 minus theta, but the sum of this angle, this total angle is 90. So this angle will be theta plus 90 minus theta, that is 90. So this angle is theta. Now here you see the normal reaction force R has two components. Here R has two components. This component, that is R cos theta, and there is a component, this one, which is named as R sin theta. So at first you write the number of forces acting here. So the force is 0.1 weight W mg vertically downwards, downwards. 0.2, that is R cos theta, r cos theta upward, r sin theta downward to the inclined plane, okay. Now here see, here by making this road inclined, an additional force arises. There is a component of normal reaction force, this component r cos theta, which is directed towards the center. R sin theta, which is directed towards the center. But in general, if r is directed vertically upward, there is no component. So here this component helps, this component provides the centripetal force. Also, if the road is rough, there is a friction also directed towards the center. So obviously here friction is also directed this way. You make separately, friction is directed this way. This is the friction, okay. So this friction has also two components. You see, this angle is theta, so this component will be f cos theta, which is directed towards the center like this way. This is the friction. So this is the component, and this is the another component, and this downward component will be f sin theta, and this component will be f cos theta. So here you just compare the horizontal and vertical forces here. Here which force provides the centripetal force? You can see in another way also, when the car is taking a turn, there is a centrifugal force which is directed outward, okay. So which force is provide centripetal force, or you can say which force is equals the centrifugal force? Which force? Here inward direction forces, you check the inward direction forces towards the center. One force, that is r sin theta, and another force, that is f cos theta. That is the sum of r sin theta plus f cos theta is equals the centripetal force. So write it. So here by comparing horizontal and vertical component, you can write this one, r sin theta plus f cos theta, that is equal to mv square by r. And you check another thing, that is the weight is equals with which forces? Weight W, that is directed downward, and there is another force which is directed downward, which is named as f sin theta. So f sin theta and weight vertically downward, and upward force there is r cos theta. So the sum of mg plus f sin theta is equals r cos theta. So write, suppose this is our equation 1, and here you write mg W, that is mg, okay, you can write mg here, mg plus f sin theta, that is equals r cos theta. So from this equation you can write which one? Okay, that is f sin theta minus r cos theta, that is equal to mg, that side, that is minus mg. So you can write r cos theta minus f sin theta, that is equal to mg. Suppose this is our equation number 2, okay. So in general case, when there is a level road, only frictional force provides the centripetal force. But when there is angle of banking, there are additional force, which is the component, one component of normal reaction force helps the body, helps the car to provide the centripetal force. That's why the banking is required. You can see in a rainy day the road is wet. So what happens when the road is wet? There is frictional force very small, there is nearly equals to 0. There is no frictional force, the surface becomes smooth. So in that condition there is no force which balance the centripetal force. So there is a probability of skidding. But to solve this, we introduce the banking. for banking, when we make the road inclined, there are an additional component of normal reaction force r sin theta and helps the body to balance it, to balance the centripetal force. So here you write, now divide equation 1 by dividing equation 2. Dividing equation 1 by equation 2. So what we can write? Equation 1, that is r sin theta plus of f cos theta, divided by equation 2, which one? This one, r cos theta minus f sin theta, and that is equal to here mv square by r, and there is mg. So m cancel out, and you do one thing here, dividing equation the numerator and denominator by left hand side with this formula. Divide this, dividing numerator and denominator by of left hand side, also left hand side by r cos theta. So what we can write? R sin theta by r cos theta, that is r cancel out, sin by cos, so this one will be tan theta plus f cos theta divided by r cos theta, so f by r, this one will be f by r, cos cancel out, okay, and this one r cos theta divided by r cos theta, so this one is 1 minus f sin theta divided by f cos theta, sorry, not f r cos theta, f sin theta divided by r cos theta, so f by r and sin by cos, that is tan, so this one will be f by r tan theta, and right hand side there is v square by rg. So now simplify this part. So this one will be tan theta plus f by r, force, frictional force by normal reaction, that is mu, tan theta mu divided by 1 minus f by r mu tan theta, 1 minus mu tan theta, that is equal to v square upon rg. Okay, so from here you can write the value of v square. See, v square equal to rg tan theta plus mu 1 minus mu tan theta. So what is the value of v here? V, that is equal to root under rg tan theta plus mu upon 1 minus mu tan theta. So this is the formula, this is the maximum velocity for which the car taking a safe turn without skidding. Okay, so this is the general formula. Now you see, you do one special thing. If the road is smooth, suppose the road, there is no friction between the road and the tires, so what happens? So first case, if there is no friction, if friction 0, if 0, friction 0, that means the coefficient of friction 0, mu 0. So when coefficient of friction 0, you use this one, what happens? V, that is equal to root under rg, this one is tan theta plus 0 divided by 1 minus 0 into tan theta. So the answer becomes V, that is equal to root under rg tan theta, only tan theta, root under rg tan theta. So this is the general equation, V equal to root under rg tan theta. From here you can find out this value also, tan theta, that is the angle of, tan value of angle of banking. Okay, find it. So from here you can write, so V square, that is equal to rg tan theta, therefore tan theta, that is equal to V square by rg. Okay, so theta, that is equal to tan inverse V square by rg. So here theta is known as angle of banking, angle of banking. Now see, you imagine what happens when you are taking a turn and our speed is very high, and we are taking a circular turn, we don't take a sharp turn, we take a turn like this way, we increase the radius of this circular path. We increase the radius. Why we increase the radius? When you see, when radius increases, you see this formula, mv square by r. When radius increases, this mv square by r, that means the concept of centrifugal force is decreases. When centripetal force decreases, obviously in the center's direction, there is the inward direction force, frictional force and normal reaction force easily balance this one. So for balancing, for safety, when we are in high speed and we take a turn very slowly, like this way, not sharp turn, we increase the radius. But when you are in slow speed, you can take a sharp turn, because when you are in a small speed, your v is small. So when v small, mv square by r, that is this value is small, and this value is small, that means the frictional force and the component of normal reaction force, you can easily balance this value. Okay, so this is all about the circular, the banking of road and the concept for turning of a car on a banked road. So I think this part is clear to all of you students. Today I am ending here. Meet you in next class. Bye bye.